How many of you have had a scraped knee or any basic worn injury for that matter? You? Me too, and lots of them. So I think all of us at some point of time in life. Now, how does body deal with such insults? Well, we've got an amazing immune system that fights off the infections, right? Yes, but sometimes the immune system of the body gets overactivated, and that's when sepsis happens. And do you know what's the sad part? That almost any infection can lead to sepsis. 30 million people all over the world suffer from sepsis every year. 20% of them die, and 70% of the survivors suffer from post-sepsis syndrome, which includes memory impairments. That means issues with memories. Memories. So memories are pretty interesting, right? They make us who we are today, or they're so important. Every day we're forming new memories and can recall that happened years ago. Now, how does brain do that? Have you ever thought about it? Like, how does brain do that? Or rather, I should be asking, when does brain do that? Any guesses? Alright, I'll give you a hint. It is a mysterious process which takes about 1/3 of our lives. Yes, you heard it right. 1/3. And on the top of that, we totally love it. Yes, it's sleep, and I am going to represent sleep today. So majorly, I've got 2 sleep states. Sometimes when I'm dreaming, I am in random eye movement sleep, and when I'm not dreaming, I'm in non-REM. So this is REM, this is non-REM. So now let's connect the dots. Sepsis can lead to memory impairments, and sleep is important for storing memories and for processing them. So in my PhD project, I focus on sleep disturbances during sepsis because that could provide us with some insights on memory impairments in septic shock survivors. So, I recorded sleep in rats during normal and septic shock conditions, and I found out that during normal conditions, this is how these sleep states look like. Non-REM, then REM, non-REM, switching to REM, then non-REM. And when I looked at these sleep states during sepsis, this is how they switched. Non-REM, REM, non-REM, REM, non-REM, REM, non-REM, REM. So the switching was really rapid. These cycles were really short and highly unstable. So we concluded that sepsis leads to sleep fragmentation. So now we knew the problem. The next task was to see how it was happening. To solve this, I classified the entire sleep recording in 2 different clusters of non-REM and REM. And I plotted these 2 clusters in 2-dimensional space. So you can imagine that this is a 2-dimensional space, and this is non-REM, this is REM. And during normal conditions, like without sepsis, normal conditions, absolutely fine sleep states, this is how they were lying in 2-dimensional space, these 2 clusters. But after sepsis, they came close towards each other. This is how they looked, like really similar to each other. So we concluded that the decreased distance between the clusters makes it easier to switch from one state to another, leading to sleep fragmentation. So with these interesting results, we propose that normalizing these sleep states could be a therapeutic target for septic shock survivors. And now, since I am playing the role of sleep here, the bottom line is that you should keep me happy, because if you don't, I might just screw up with your memory. Thank you so much.